please welcome Gary Bolton, our moderator for To Infinity and Beyond, AI, Quantum, and Telecom.
Lucky for you, that's what I like. That's what I like. Lucky for you, that's what I like. That's what I like. Search by the fire at night. Silk sheets and diamonds, all white. Lucky for you, that's what I like. That's what I like. Lucky for you.
Well, good afternoon, everyone. Or morning, I guess we're still in. So welcome to Infinity and Beyond, AI, Quantum, and Telecom. You know, the broadband industry is experiencing one of the largest infrastructure investment cycles in American history. You know, by the end of the decade, fiber will reach nearly every home and business, school, and community across the country. But at the same time, we're witnessing another historic transformation: the rise of artificial intelligence, quantum networking, cloud computing, and machine intelligence at scale, unlike anything we've ever seen before. And as I talked about on Monday, these are not separate trends, but they're converging. AI doesn't exist without connectivity. Quantum networking will not be at scale without ultra-high performance infrastructure. And every breakthrough application, from autonomous systems to immersive experiences to smart manufacturing, telemedicine, and national security, depends on networks capable of moving massive amounts of data with near zero latency, absolute reliability, and virtually unlimited scalability. And of course, fiber is the foundation that makes all this possible. So this panel is about helping our audience understand how the convergence of fiber, AI, cloud, and quantum technologies is reshaping the communications landscape, and where the greatest opportunities exist for operators, infrastructure providers, technology companies, and investors. And we're fortunate to have three outstanding leaders with us today. Juan Colina, the Managing Director of EMEA and APAC at MTEL Group out of Dubai. Amy Wheelus, the Chief Technology and Information Officer at Giga Power. And Mario Castro, the Vice President of America's Cloud and AI Infrastructure at Cisco. So thank you guys for joining us today. So let's kick things off. So Amy, let's start with you. So you spent 3 decades at AT&T, and you became employee #1 at Giga Power, helping to build a new open access platform from the ground up. So as AI accelerates the demand for high capacity, low latency infrastructure, how's Giga Power thinking about the role of fiber in this whole next generation applications and supporting the broader AI economy?
Thank you. We believe that fiber and broadband are the core enabling technology that's going to drive the future. This is about, as you look to the future, as AI accelerates, as quantum starts becoming a reality, those things are going to need the depth, the symmetry and resiliency, and the reliability and security that are greater than we've ever imagined. What we know today didn't exist 10 years ago, 20 years ago, 30 years ago. If you think back in history, it took 100 years to go from the first phone call over copper to the first call over fiber. And then in the last 50 years, that technology and the capabilities of those technologies have seen a millionfold increase. And so today, the depth that we put into place to build the scale is critical. You have to build for the future now. We can't get to the future and say, oh, our network can't support it. And so as we think about the future, we're thinking about how do we enable that scale through fiber to the homes where we live and play, to our businesses where we work, and to the supporting infrastructure that will make AI happen, the hyperscalers and things like that. So fiber is a core enabling technology that gets us there.
Before we leave you, Amy, can you just, I think everybody knows Giga Power, but can you just tell us this quick history of Giga Power and then where you are on your deployment?
Yeah, so Giga Power is a wholesale fiber-based broadband network operator. We build and operate the network, and then we wholesale to customers. AT&T is our anchor customer. They are also one of our owners. Our other owner is BlackRock, the infrastructure fund within BlackRock. And what we are doing is we are live in 8 markets across the United States. We had our 3-year anniversary last week. And we are well on our way to the 1.5 million commitment that we had from our initial funding. We are in the midst of looking at the future and where do we go next? How do we scale next? What's the next challenge for us? And this infrastructure space is clearly within our vision for how we're going to go forward.
Thanks, Amy. So Mario, Cisco, it's funny, we did our documentary and had one of your founders talking about building routers in his living room, and he was both the CTO and the chief manufacturer and everything, so it's kind of funny and interesting to see where you guys come to now being really in the crosshairs of whole AI infrastructure and AI transformation from networking and data center architecture to cloud connectivity. With AI infrastructure becoming one of the fastest growing technology investment areas globally, how is Cisco viewing this opportunity, and what changes do you see in how networks are being designed for the AI era?
Thank you, Gary. So first and foremost, I think thank you for recognizing the journey that Cisco's been on. Quite frankly, we have come to be known as the plumbers of the internet in every aspect of connectivity, and we're going to continue that momentum as we get into quantum and probably even beyond that if we can. But what I would tell you is this: like the infrastructure and the need for networking and the opportunity to use fiber rather than copper to provide connectivity for east-west traffic versus north-southbound traffic has grown significantly. What we're finding now is that the hyperscalers and the web scalers and anyone that has interest in really expanding and growing their AI footprint are looking at fiber as the best way to provide that connectivity. But if you pause and think to yourself, like 90% of the traffic that's being handled today is in the data center, and the expectation is that at the edge eventually, when inferencing makes its way out there and enterprises start to embrace it, any community actually starts to embrace it, that data centric is going to shift from being in the data center or hyperscalers or wherever you want to park this data out towards the edge where a lot of this inferencing will happen. So we're thinking about 75% of that data will be moving out towards the edge over the next 3 to 5 years. If that happens, then clearly you need connectivity out at the edge to be able to process and demonstrate value in terms of how you take this information and utilize it and operate the business that you're using that to do with. But more importantly, like we're seeing AI now move from a cost center where it's like, hey, it's great to deploy these technologies and maybe improve, bottom line or some other outcome within an organization, to turning it into a profit center or some way to maximize safety, security, as an example, as our customers are deploying technology. So what we're seeing is a tremendous example of growth across all areas. And because AI continues to grow and go beyond predictive, beyond generative into agentic now, and then ultimately we'll see where we get into humanoids and additional physical AI scenarios. There's just more and more data being created, Gary. And I'll tell you this: like, if you don't have an idea of what a zettabyte of data looks like, imagine every granular piece of sand that exists globally in the ocean floors and the golf courses, wherever you find sand, and treat one little grain of sand as a bit of data. That's close to 1 zettabyte of information, and we're generating information in constant form. So somewhere along the line, this data has to reside and be processed, and also be moved in a way that it allows us to continue to evolve the path. So I see fiber being a really critical aspect of how we accomplish that.
It's funny, when I play golf, it seems like there's a lot of zettabytes of sand where my ball
Step
goes.
all over it.
And the other thing you mentioned I thought was interesting is you guys are the plumbers, and what Dr. Kaku had mentioned, that plumbers will still be around in the AI era, so that's probably a good place to be. So one, I had the pleasure of being with you in Dubai and then again in London, and your insights on data centers and hyperscalers and where we're going with AI. Can you talk a little bit about, you obviously have a very strong optical background. Can you talk a little bit about your career journey and then what you guys are doing with AI and data centers?
Yeah, thank you, Gary. So look, at MTEL Group, we are developing solutions to enable data centers to deploy faster, but also telecom operators to bring the capillarity on the network that is required. One thing that we're seeing across data centers, it came out through the last 3 days in discussions here, is the same in EMEA, is really around power. Power being the major issue that we see across data centers. That's really what is going to enable artificial intelligence, but also the next stages of artificial intelligence, artificial general intelligence, artificial superintelligence, but it all comes down to power. But it's been addressed. I think the next problem and the bottleneck looking 3-5 years into the future is going to be around around optical fiber, and how fiber, the capillarity on the network. Mario mentioned edge. I think edge, when we start understanding that all the optical devices at the edge are going to enable inference, and you're going to have mobile phones, and you're going to have endpoints that are about 4 or 5 times larger than the number of endpoints you have in a fiber to the home network, then you start understanding the amount of fiber and the capillarity you're going to have to bring into places where infrastructure providers today understand it's very difficult to get into the house. It's very difficult, that last mile. Well, that's really good learnings to be able to deploy the capillarity and the density that edge networking and edge compute is going to require.
You know, I always think about this stuff as it's in the future and it's coming, and then all of a sudden you see a press release, NVIDIA doing a trial with Pulte Homes on putting GPU racks in people's houses, and so it's scary how quickly things are happening. And we really, for me and our industry, I think we have to be able to move quick. So everyone talks about AI and quantum as the future, and this is a little self-serving, but why is fiber the prerequisite infrastructure that makes that happen? I'll just throw it out. Anybody who wants to take that one.
Well, let me give you a couple of thoughts, and this ties into the power conversations that we're having. So fiber clearly does not draw as much power on the optics and the rest of the infrastructure that it requires to be able to drive over the existing connectivity that most people use, right? Secondly, what you're going to find is that as the speeds continue to increase, so we're going from 800 gig now to 1.6T, and we're expecting that to continue to evolve over time, we're not expecting that the copper is going to be able to handle that, right? And then the other piece that I think is really interesting as well is that, we've heard in more than one session here that power is really the creator of success for AI. So not only is it important to figure out where we get the power, or where we find ourselves making sure that we can deploy AI solutions with the right power that we have, but we also need to do our part to reduce power. Not just find it, but to reduce it. So like as you move from copper to fiber, that's going to reduce it. As you change the hardware configuration, that's going to reduce it. There's another outcome that's being explored, and you'll already see some patents out there that are floating around, and that is actually you start to drive this technology with direct current instead of alternating current. And that in itself also saves another 30% of power reduction. So like all of that is just coming together very nicely to allow us to continue to evolve the use of fiber as we deploy. And I know we'll probably talk a little bit about quantum at the very end, but I'll share with you like why we think what you said is a reality, because quantum is absolutely going to need fiber to be successful in that.
It's interesting, when you think about the battle between Nikola Tesla and Bell on AC versus DC, it's coming full circle. And then, Amy, you guys have the benefit, like your parent, you're one of your owners, AT&T, they had their legacy network, they have to upgrade, and a lot of challenges with trying to, but you've been able to do it from scratch. When you're building your network, I mean, I get frustrating when people just want to say, we got, politicians and so forth, or just need to connect homes to the internet. Well, I'm thinking we got to connect to the future, but are there things that you guys, as the CTO, that you're thinking about as you design your network and build your networks, not only just being able to connect to the internet and do the things that we've been able to do today, but as Michio Kaku, it's not just making your TV work, but what are you thinking about, and how do you architect?
Yeah, so when we were starting, and I tell people that my job as CTO was an easy job because I had a clean sheet of paper, green field. But we wanted to be very simple in our network architecture. We also wanted to make sure that whatever technology we chose was software upgradable. And today we are software upgradable to 25 gig. We provide 8 gig today. Today, homes can't consume 8 gig. But in the future, as Mario was saying, if if we start putting CPUs in the home to do some of these workloads in the homes, then they will need 8 gig. They will need more than that. They will need 10, 25, because moving data is not just a one-way thing. It's both, and that's where fiber is the enabler, in that fiber gives you that symmetrical speed capability, that two-way communication that is so much greater than any of the hybrid technologies. And so you have to have end-to-end fiber all the way to the home to be able to do that. And so as we've designed, we started, and our mission is really residential, connecting homes back into the network. But then as you start to expand across a market and across a geography, then you start putting in place that next layer of connectivity, the next layer of rings and technology, so that you can start picking up the enterprises and have direct connections from people's homes to the places they work, or to the data centers that are being put there to consume that AI capabilities that everybody's starting to use.
Yeah, one of the things we talked about is, we have 1,561 fiber operators now. We're entering the market consolidation phase of our industry, and you've had the benefit of building from scratch with a potential exit, with being repatriated back in AT&T. But what does every operator in this room need to think about as they're building their fiber network?
I think the thing that's very important is standardization, because with 1,400 plus operators, there will be consolidation. And the way to scale the consolidation is not through big commercial deals. Don't want to upset any of the equity and financial people in the room, but the way to really scale and speed up that merger and acquisition activity is to have standardization, so that you don't slow down and have to recreate things and take away from your valuation, because you've got to put in more capital to make the integration work.
So one, as AI workloads are exploding, are we underestimating the amount of fiber infrastructure and transport capacity that the future is going to need?
Look, I think we are. I think we certainly are underestimating the amount of fiber needed. Just as an example, 1 megawatt of compute capacity within a data center requires around 15,000 terminations if this is for a cloud and storage data center, and about 35,000 terminations if it's an AI-ready data center. And then those terminations have to go into other switches and routers and meet-me rooms, and then you got to build the network capillarity of redundancy and connect, as Mario was saying, east to west traffic within the data center, but then north-south traffic in and out of the data center. And that's just today for the current training and inference facilities. The moment we start looking at edge, and just think about edge communicating with, obviously, not only your mobile phones, but communicating with autonomous vehicles, communicating with emergency vehicles, communicating with enterprises, Wi-Fi 6, Wi-Fi 7. The number of endpoints in the network is going to quadruple, quintuple over the next 5 years. So we're going to have to put a lot more fiber in the ground, not only on the metro, which is really happening at the moment, but then seeing that through into the access network, into the distribution network, into the drop network, for all the different endpoints that we're seeing. So 1 megawatt is 15,000. In the US at the moment, the amount of compute capacity that is going to be added just for data centers alone over the next 5 years is going to be 10 gigawatt. So you're getting into the billions of optical terminations within data centers. So like that long-winded answer, but in short, yeah, we definitely are underestimating the amount of fiber that we're going to need.
We need a few fiber optic splicers, it looks like. So, Mario, you mentioned, we kind of live in a north-south world, and now we're east-west, and now every which direction of, so what are the biggest architectural shifts happening inside telecoms and cloud networks, and how are operators preparing for these AI scale traffic and compute demand?
The industry has been actually heavily focused on either co-location or data center. You've got the hyperscalers, you've got the neo cloud providers, and then customers reimagining again what their data center is going to look like for the future. So all of that is shaping what that looks like. We talked again about the edge and the inferencing that needs to happen there, and I like what Juan was saying. If I just give you an example of the intelligence and the importance of connectivity and being able to process all this data. Again, the data center aspect he just communicated, but I'll give you an example of one here in the Lake Buena Vista area that is being tested here in Orange County, and that is an application called No Traffic. No Traffic is actually an AI intelligent application that utilizes real-time information from traffic to be able to make decisions on the flow of the traffic. Now, that's a big difference in the way that many of you may be familiar with how intersections are handled today, which is using predictive information, machine learning information that has been collected over time that says, hey, at 9 a.m. or 7 a.m. we expect heavy traffic, and so we're going to modify the intersection in a way that we're going to allow traffic to go in the manner in which it needs to flow the fastest, right? But that's just regular information that's not in any way, shape, or form really making a big difference in terms of how traffic is managed. Now imagine this inferencing that's happening at the edge where the compute and everything is handled there. Now you've got a child crossing the street at the intersection, but the light's getting ready to change green and the traffic is getting ready to flow, but because the cameras are actually picking up the child walking across the street, and it knows and bases on the time of travel that he or she is not going to be able to make it across the street, those lights are not going to change, right? So now you're actually seeing real-time information being utilized to provide safety, security, risk. An ambulance has come in, let's move traffic, let's keep the lights going so that the ambulance can come through. There are all sorts of different scenarios, and all that information has to be processed, but then it also has to be sent back somewhere to be analyzed over again, retraining. The whole models need to be evaluated so we can continue to evolve as we see the traffic coming in. So it just really makes a huge difference in terms of how we see the momentum of using AI, agentic AI, and some of these other tools that we are finding ourselves in front of to dramatically change the way we experience life today.
Yeah, Gary, can I add something
Yeah,
to
please.
that? So, Mario makes a great point that, as we, and what Juan said earlier about as we increase the number of endpoints, and as you said, as we move from predominantly a north-south traffic to an east-west traffic, we spent the last 20 years preventing east-west traffic on our networks. And the security world and the security infrastructure is seeing a major fundamental shift. And that's one of the areas that doesn't get a lot of talk, but it's one of the very key issues, because as this becomes more and more interrelated to life safety, the example he was just talking about where you have a child walking across the street, then that security and ensuring that the security of the data is of utmost importance. And if you think about all the valuation markets and all the trading markets, I think that's an area that we're going to see a lot of growth in, and that fiber is going to continue to enable, because they're going to need the same type of bandwidth running in parallel with the AI to be able to secure that AI information.
It's interesting in that, so everybody here sees the press releases of the billions and trillions of dollars that hyperscalers are throwing into AI infrastructure. And, when Juan and I were recently in London, and it was kind of interesting because there was people talking about AI infrastructure and hyperscalers, and then there was telecom operators talking about connecting homes, fiber to home, and those two conversations didn't connect. And when you come here, thankfully, every operator I talk to is trying to think about that. But how is this whole trillions of dollars being in for AI really reshaping the opportunities for fiber providers, the people in this room, and especially one with your experience in Europe and what's happening there? What is that, and how do they participate?
I think the way the networks are being built here and the call it granularity of operators throughout the states, I think is fantastic to build the infrastructure, because I don't think there's many people building for, fiber to the home or building for data centers. We're just going to build the network and building the infrastructure, and we're going to put it in the ground, and we're going to dig the ground once, and we're going to make sure that it's at the infrastructure layer future ready. And maybe then on the optical side, you eventually do these things incrementally. but there is a lot of happening on the network upgrades and builds to get enough infrastructure for hyperscalers, but edge. And so we were discussing earlier, I think we, like here in the States, like it's not even the end of the beginning. I think it's really just starting to pick up pace where over the next 10 years, the amount of fiber is gonna be increasing exponentially across every single portion of the network. So for operators here, for people that is building the infrastructure, I would really only say that if you are going to dig, if you are going to open the ground, I would suggest put as much as you can at the very beginning to eventually enable that steady growth as you increase the demand and you increase the number of customers on your side, because it is going to become critical. And I think at some point there will be shortages and there will be issues getting access to labor and there will be issues getting access to fiber and there will be a lot of issues. So it will be smart to just put as much as you can on the ground at the very beginning.
It drives me crazy when I see people in our industry, you know, complaining, well, AI guys are taking all our memory chips, AI guys are taking all our fiber, AI guys, you know, we don't want them in our town. You know, and it's happening, right? And we have to participate. And one of the things that I worry about when I'm trying to sleep or not sleeping worrying about it is that this AI wave is happening so quick that our industry doesn't figure out how to participate. You know, as we move inference to the edge, you know, these guys with bottomless checkbooks can do whatever they want with just writing a $1 billion or $1 trillion check. And how do we make sure that we participate? But Mario, you think that this industry, I mean, we have a good track record,
yes,
right?
We
so
do.
how do you see this thing playing out?
You know, the good news is that we've been doing edge connectivity for quite some time, and the one thing that will probably change here is inserting AI into that conversation. Now, if you consider over the years, and by the way, I'm an old person, you just can't tell because of the color of my hair, but I've been in the industry when this started to evolve and a lot of this this technology started getting pushed out to the edge, client server, you know, connectivity, traditional, muxing before it became routing, all these transformations that we've had. The service provider space has always been mixed into that to support our customers at the edge the best way they can, and that's because they don't have the talent at the edge to be able to support like a retail office or some complex dwelling where the businesses are on the bottom and the homes or apartments or condos are on the top, right? Like somebody needs to be able to go out and provide the support and the help that these customers need, and I see this as a tremendous opportunity for the service provider space to take advantage of that, especially with the fiber connectivity that we're talking about. So the reason why I bring that up is because, you know, I gave the example of an intersection. That's a smart city. I just gave another example of a multi-dwelling environment where you have businesses on the bottom and homes on the top. You can drop in, and you mentioned it earlier, Gary, you have compute that needs to be at the edge. You have accelerators that complement that for the GPU side to actually analyze the information. You have the network piece that provides the connectivity to whatever it is that you're actually monitoring. It could be physical security cameras. It could be lights. It could be whatever the environment is looking for. You're also going to need the storage to be able to process the data that's being handled, right? So all these technologies exist today. The challenge is that for customers, when they start adding AI to the conversation, it gets a little more complex. And more importantly, the security piece that a lot of times people forget to add into or in front of the AI, like secure AI factory as opposed to an AI factory. It's hugely important to have that part of it as well. And then the last piece is observability, because you need to know what you can't see, especially if you're using technologies like broadband services where you don't have the window to see what's actually happening and where the delay's at, or whether it's an application issue or hardware issue, or you name the journey that packet's taking. So all of that is actually evolved to the point now where we can hand off a platform, a small example, and this is across multiple vendors, a small platform that allows you to provide all these connectivity requirements that are necessary to expose AI and allow AI to be used at the edge. Now, this is where the hyperscalers and the web scalers need to partner with the service provider and the ecosystem to be able to deliver that. Because the hyperscalers and the web scalers built themselves to be able to bring customers to their facilities, not necessarily to turn around and start pushing back out towards the edge where a lot of this traffic will be handled, right? So fortunately, you have options there on the horizon that you can pick from that allow you to go ahead and deliver these AI-centric services at the edge to be able to support, clinical environments. Transportation, we talked a little bit about that already, a smart community, and the likes of factories and other things. So I think we're in a really, really solid position to do that. And I encourage you to continue to evolve in the awareness that needs to happen there, so that instead of deploying 6 or 7 different technologies to deliver that, you're deploying one box that allows you to create what I call a data center-like supported environment, but you're doing it at the edge. So definitely, see what you can do to learn a little bit more about that.
Well, I just want to thank my panelists. Hopefully you guys take home with you that as you build out your networks and do your deployment, that you're thinking about how what you're doing today is going to fit into the AI and quantum future. So join me in thanking Mario, Juan, and Amy.
Lucky for you, that's what I like. That's what I like. Lucky